Okay, I think I'm recording. So I wanted to do an example of a Calc 1 problem from the past where our goal is to perform some sort of optimization. So I don't have my iPad with me, but I want to record this video. So I'm going to do this on paper. Optimization. See if I can get better focus on this. Better. Okay. So an example of something you might have seen a long time ago is something like this, where a farmer, let's say example, this will be example number 1. I might have an example number 2 in another video, but I'm just going to call this example 1 because it goes with a certain node set that I call the fmincon node set. We'll talk about what this means in regards to MATLAB. You'll need it for your project. But the example is a farmer has 200 yards of fencing, and they want to enclose some rectangular area where the area consists of 3 fence lines and 1 wall. Fence lines and 1 wall. So if I were to draw a picture, here would be our wall. These are our 3 fence lines, 1, 2, and 3, and then this is our area. And we want to find the dimensions of this. Perhaps I call this X and I call this Y, and the goal is to find the dimensions that maximize the area. So find dimensions X that maximize the area. So this is an optimization problem. The general idea behind this is that we have to come up with equations that will allow us to determine the appropriate variables X and Y. And our general idea here is that we have some sort of constraint. So we have a constraint. Our constraint in this problem is what? Well, the constraint is that we only have 200 yards of fencing. So our constraint is that we have 200 yards of fencing, of material, let's say, or of wood or something. And the thing we're trying to optimize, this is what we call the objective function, the objective function. This is the area. We want to maximize this. We want to maximize this. We want to maximize the area. That's what the farmer's trying to do. So we have to come up with equations for these two things. Well, our area is pretty simple because our area, this is our objective function, is just equal to X times Y. Now, if we were in calculus, when we do maximum or minimization problems, what we typically do is take the derivative of this function, set it equal to 0, and then we would solve for the variable. But we have 2 variables here. So what do? Let's come up with an equation for our constraint. Because we have 200 yards of material. So that means that we have X yards being used there, Y yards being used there, and another set of X yards being used there. So our constraint equation is that 2X plus Y has to be equal to 200. This is our constraint. That's our constraint. So what we can do is kind of like a substitution type of thing. We can say that y is equal to 200 minus 2x. And now that we have an expression for y in terms of x, we can plug that in right here. And then we have an equation that's just in terms of one variable, just x. So let's take this, and we'll go ahead and plug it in right there. So our area will now become x times 200 minus 2x. If we distribute that, we get 200x minus 2x squared. And this is the thing we want to maximize. So find x that maximizes a. Sorry for my poor handwriting with the marker. So if we were to draw a picture of that graph, I'll write down the equation again. A is equal to 200x minus 2x squared. This is a parabola because of the x squared. So if we were to draw something, we would see some graph that kind of looks like this. And the location, if this is x and this is the area, there is a specific value of x. This is what we want to find. This is our, that's our good value of x there. I just put a little star to say that's the one we want to find. That's our ideal x variable. And at that location, we know that the slope is 0. So what we'll do is we'll take the derivative of a with respect to x and set that equal to 0. That's our goal, and we solve for x. If we take the derivative of this with respect to x, we get 200 minus 4x is equal to 0. We can solve for x, and we end up getting x is 50. So this value here says that x is 50. Okay, now let's come back and find y. Y is equal to 200 minus 2x. So if we plug in 50, we get that y is equal to 100. So if we were to draw this picture again, we would say that this is 50, this is 100, this is 50. We see that the sides of these three fences add together to give you 200, the amount of wood that we have. And if you were to plot this function in MATLAB or something, you'll see that this point here is 50, comma, what's the area? Well, 50 times 1,000, or 50 times 100 is 5,000. And that will be our maximum area. So we will talk about this in regards to MATLAB shortly, but I wanted to put this up here as an example to remind you how optimization problems kind of work. We have a bunch of variables, possibly more than 2, that define some objective function. And then we have constraints that are a part of the problem that determine or constrain our ability to create an area. So with these two together, we can figure out what the appropriate x and y are that yield the best results. So keep that in mind. We'll talk more about this in the future, but I wanted to post a video now just to bring you up to speed with things from the past. Okay, thanks.